Okay, let's go ahead and do problem number 7. Obviously, we're still working on solving systems of 3 equations and 3 unknowns. I am going to do this one by elimination. So remember, for elimination, we need to pick a target variable that we are going to eliminate twice. And I would definitely focus on a variable that has no coefficient visible other than 1. So I'm looking at this z right here, and I'm really liking it. So I'm going to use the z's. So with that in mind, I'm going to eliminate all the z's like this. Okay, keep your eye on the z's. Now remember, for elimination method, I like to take these 2 at a time. So I'm going to make a new system, and I'm going to use the top 2 equations with my little z in it, and I'm going to color those blue. And then I'm going to use my bottom 2 equations, and I'm going to make those red. Now, it doesn't always, every problem you've ever seen me do, I've always used. In fact, you know what? Maybe for once I won't do it this way. Alright, I'm going to use my top 2 equations, but then instead of using my bottom 2 equations, I'm going to go ahead and use the top and bottom equations like this. Okay? It doesn't have to be the top 2 and the bottom 2. I'm going to do the top 2 and then the top and bottom together. Okay? In fact, maybe I'll make these arrows match. So I'm going to do these 2 in blue, and then I'm going to do these 2. Alright, so here we go. Alrighty then. So, as promised, I've recopied the top 2 equations shown here in blue, and then I took the top equation and the bottom equation, and I've written them in red. So this is how you do elimination. You make 2 pairs of equations, and you eliminate the same variable in both. Right from the beginning, I decided I would eliminate the z's. So in the blue equation, if I want the z's to go away, I would like this z to become 3z, so it will cancel. So that's why I'm going to multiply the bottom equation by 3. Okay, and let's see what happens if I multiply the bottom equation by 3. Now, of course, this top equation is just going to come down unchanged, just like this. Okay, it's the same exact equation. I didn't change anything. Now I'm going to distribute this 3 across the equation and see what I get. And here's the equation I get after I multiply everything by 3. So I want to combine like terms, because my whole point was to get rid of these z's, eliminate the z's. So they're gone. But now the rest of it, I'm going to combine like terms. So this is going to make 27x minus 13y is equal to 199. Alright, that's as far as I can go with the blue equation, so I'm going to go ahead and put a box around that for right now. Now let's do the same thing with the red equation. Okay, now this is beautiful, and which is one of the reasons why it was smart to use the top equation and the bottom instead of just the bottom 2, because you see I've already got opposites for those z's, so I don't even have to multiply anything. I can just start combining like terms. So those z's will cancel each other out right away, and so that's going to give me 8x plus 10y is equal to negative 38. Alright? I started to say that's as far as I can go with this equation, but I'm noticing that these are all even. And I like to make the numbers as small as possible, so I'm seeing that common factor. So I think it would be smart to divide everything by 2. to make the equation have smaller numbers, but yet it's still the same equation in another form. So this equation then becomes 4x plus 5y is equal to negative what? 19? Okay, so this is the equation I'm going to go with. Alright, you didn't have to reduce it like I did, but I would divide by the greatest common factor if you notice it. Working with smaller numbers is easier than working with larger numbers. Alright, it's time to take these two equations and stack them up and solve them using elimination. There's only two variables, so elimination should work. The numbers are kind of ugly, but unless I made a mistake, it should work out. So let's just see what happens. So if I take the blue equation and stack it up over the top of the red equation. Alright, now that is going to give me this. Alright, I don't see any way to avoid having some ugly numbers here. Let's go ahead and try to eliminate the y's. So we're going to have to multiply both of these equations by something in order to make that happen. Looking at the y's, I see the 13 and the 5. What always works is to switch these up. Okay, so I'm going to multiply the top by 5 and the bottom by 13. Okay, watch what happens when we just sort of reverse those numbers as we multiply. So this is what you get if you do that multiplication throughout. Of course, the y's are going to cancel just like we wanted. Combining these like terms, you get 187x and then 748. Isn't 187 the police code for homicide? If so, I've been watching too much TV. Anyways, if I want to get the x by itself, I need to divide both sides by 187. Okay, and if we did this right, this should go in evenly. I just remember that this wasn't a decimal or a fraction. Which isn't to say that it could never be. It could be, but it's not today. So that does go in evenly and makes x equals 4. So that is one of our values. Okay, that's the first one we found. We need to find the rest. Let's start by finding the y value that goes with this. Okay, we can take this x and plug it back into either one of these equations. I'm liking the red one a little bit better. So let's go with that option. Okay, so looking at the red equation, I'm just going to recopy it here in purple. So that's 4x plus 5y is equal to negative 19. But now we know that x is 4. So if I just take this and substitute it in, then that's going to give me 4 times 4 plus 5y is equal to negative 19. So that'll be 16 plus 5y is equal to negative 19. Subtracting that 16 from both sides. So that's going to give me 5y is equal to negative 35. Okay, so if I divide both sides by 5, at this point, you guys can see where this is going, can't you? So that's going to give me y is equal to negative 7. Okay, so those are the two values that I got from putting the blue equation with the red equation and solving it like normal. Now that we have the two answers, these two variables, I can always plug them back into one of the original equations. Any one of these original equations up here. So I'm just going to pick whichever one seems the easiest. I'm liking the bottom one today. So looking at the bottom equation, I'm just going to pick it and I'm going to recopy it over here so I can substitute. So I've got 2x plus 8y plus 3z is equal to negative 21. Alright, so looking back, you know what, maybe I'll copy this down below. I think I'm going to do that. Alright, so here's that equation. Okay, that's really the third original equation. I just copied down here because I have more space. So substituting 4 for x and negative 7 for y, this becomes 2 times 4 plus 8 times negative 7 plus 3z is equal to negative 21. So that's 8 minus 56 plus 3z is equal to negative 21. Subtracting, that's negative 48 plus 3z is equal to negative 21. Adding 48 to both sides, that's going to give us 3z is equal to 27. And then finally divide both sides by 3. And that will give us z equals 9. Alright, and with that we have all three variables, x, y, and z. So let's go ahead and record our answer as an ordered triple in the form x, comma, y, comma, z. Alright, and that would be your answer to problem number 7 by elimination.